VSEPR Theory. A valence shell electron pair repulsion theory is a model used in chemistry to predict the geometry of individual molecules from the number of electron pairs surrounding their central atom. This model assumed that the electron pairs will arrange themselves to minimize the repulsion effect from one another. In other words, the pair of electrons are far apart from one another. The VSEPR theory is very useful for predicting and visualizing the molecular 3D structure. There are different postulates of VSEPR theory. Let's look at them in detail. The first postulate of the VSEPR theory is that the pair of electrons are arranged in a space around the central atom in such a way that the distance between them is maximum and the electron pair repulsion is minimum. Let's understand it through an example. Let's suppose we have an Ab2 molecule with a central atom as an A and a terminal atom as a B. According to this statement, the atom will arrange themselves in such a way that the distance between two AB atoms is maximum. So it will form a linear structure with 180 degrees in between two terminal atoms around the central atom, which is the maximum distance between the two bond pairs. The second postulate is that the electron pair which forms a bond is called a bond pair, and those electron pairs which do not form bonds are called lone pairs. Like in the water, we have two bond pairs and two lone pairs of electrons. A lone pair of electrons is capable of occupying more space on the central atom than a bond pair. It means that the repulsion caused by a lone pair, then the bond will push the other electron pair as far as possible. For example, the molecule BF3 has 3 bond pair electrons, so the angle between each pair is 120 degrees. But in the stannous chloride, there are still 3 things around the central atom. Unlike in BF3, in stannous chloride, one lone pair of electrons is present around the central atom, which pushes the bond harder, and the angle between the two bonds decreases to 95 degrees. The next postulate of VSEPR theory says that as the bond angle increases, the repulsion between the two bonds will decrease, and is very obvious because in the Coulomb law, the distance between the two charges is inversely proportional to the attractive or repulsive forces in between the two charges. The next point is that the multiple bond and the lone pair occupy more space than a single bond, and the bond angle will change in molecule. Like in BF3, the angle between the bond is 120, but in stannous chloride, the bond angle decreases to 95 degrees because the lone pair of electron presence pushes it hard. The next point is that the multiple bond behaves as a single bond. So the double bond in carbon dioxide and the triple bond in hydrogen cyanide still have a linear geometry just like beryllium chloride. The next postulate is that when the electronegativity of an atom increases bonded to the central atom, the bond angle increases, because the pair electron will be attracted more towards the electronegative atom, which will give more space to the other bond pairs, and the angle between them will increase because they will have space available. Thanks for watching this video.